I am Dr. Munish Kumar Bhardwaj from School of Engineering and Technology of IGNOU. And today we will be discussing about the strengthening and repairing techniques. Till now we have discussed about sources of various kinds of defects, various stages of design and construction which may be the source of defects, also different type of cracks based on the orientation, various type of cracks according to their nature and the place of occurrence, and also the equipments for diagnosing the defects. Now, in this lecture we will discuss about the classification of defects and strengthening and repairing techniques. The objectives of this module are that at the end of this module you should be able to classify various type of defects, and also you should be able to explain different strengthening and repairing techniques. Now let us begin with classification of defects. Defects can be classified into two categories broadly. First one, structural or physical defects, and second one is defects due to chemical action. So let us first begin with structural or physical defects. In this category, the following type of defects can be encountered. What are these? First one is settlement cracks. Settlement cracks in supported masonry walls due to overloading beyond the load specified in the design. That is, width or depth is insufficient in relation to bearing capacity of the subsoil. So if this is the case, then there will be settlement there, and due to that the cracks will appear, which you will call as settlement cracks. Building used for a purpose different from that for which it was designed. So here the loads taken for the design will be different now, because the design was, for example, the design was for residential purpose, but later on you are using as a warehouse, though certainly the loads are going to increase. So that way this building used for purpose different from that for which it was designed will certainly experience some problems, some damages. Then structural alterations, that whatever was designed, whatever was constructed, later on you are changing some structural elements, you are bringing in some change. For example, formations of large openings in the wall to accommodate some new doors, some new windows. So that way it is going to affect the building. Then concentrated load on adjacent foundations, that on the adjacent foundations some concentrated loads are coming, then there will be settlement. So due to this settlement there will be cracks that you will consider as settlement cracks. Then causes for structural defects. What are these causes? Shrinkage of clay subsoil due to withdrawal of groundwater by prolonged drought, that there is a prolonged drought and the excessive water is being withdrawn from the ground. So that way there will be shrinkage of the clay subsoil. If clay is there in that, so it will be a shrinkage of clay on drying. So certainly it is going to cause problems, defects in the structure. Then presence of fast growing trees nearby. What happens that if there is some fast growing trees there nearby the building, then the roots of the tree will be putting pressure on the foundation or the walls. Then ultimately what will happen? Stresses will be coming into the structure and there will be cracks in the walls, other structural parts of the building. Then another problem is of improper site drainage. If drainage at the site is not proper, then certainly that water which is standing for a long time, it is going to cause some problems in the building. Then another problem is of tunneling. If it is there, then certainly it is going to do some damage to the building. The next is undermining of foundations as a result of finer particles of sandy soil being washed out by underground streams. If some underground streams are there, then it can wash the finer particles of the sandy soil, and due to that there will be undermining of the foundations, and their failure of foundation or settlement of foundation will be there. Then flooding or leaky drains. If drains are leaking, then certainly it is going to cause the problem in the building. Then long term settlement of the peat. Problem is downhill creep of clay soil. Another is shallow holes and mine working under the foundation. If some holes are there, if some mine formations are there under the foundation, then certainly settlement of foundation will occur. New excavations immediately adjacent to the building to greater depth than the old foundation. Means some new construction is going on, and if the excavation is deeper than the existing building, then due to this deeper excavation, there will be effect on the old foundation. Foundation of extensions, bays, screen walls, etc. with shallower foundation than those to the main building, then also there will be a problem. Another factor is vibrations from heavy traffic, machinery, piling operations, tunneling, etc. Because if heavy vibrations are there, then it may cause problems in the structure, nearby structures. The structural defects in the external walls could be seen as diagonal cracks due to settlement. Due to omission of expansion joints in long length of walling, structural cracks occur in the walls, sometimes resulting in outward bulging of the wall. Displacement of walls occur due to any of the following reasons: thickness of wall insufficient in relation to height, inadequate lateral support to the wall, overloading of structure, and finally vibrations from heavy traffic or machines. Defects due to chemical action. Chemical action in brick and stone masonry originates basically from the chemical reactions of the constituent minerals and the atmospheric gases. So if these two combine, then certainly the chemical action will occur. In case of brick masonry, white powdery deposit in the form of efflorescence is caused by crystallization of soluble salts in bricks or mortar. Spalling of surface can be caused due to sulfate attack, crystallization of salts in outer layers of friable bricks, means the bricks which can crumble under the hand pressure only, and also weathering of underburnt bricks which are less durable. Means this effect can be seen in two cases. One is friable bricks and second one is underburnt bricks, because these two are less durable. Another defect is the bowing of brick facing to concrete wall, and the cause for it is the differential movement, that is drying shrinkage of concrete with the possible moisture expansion of freshly fired bricks. So these are the two opposite phenomena, that here at one place shrinkage is occurring in the concrete, and at another place there may be a possible moisture expansion of the freshly fired bricks. When the two things, bricks and the concrete, are being placed together. Staining of bricks is caused by runoff from concrete roof or external stairs or washings from limestone features. This may also be due to leaking gutters, cracked rainwater pipes, or overflows with inadequate projection. Next is stone masonry pitting and staining of limestone plinths. This can be caused due to damp-proof pavement finished at a higher level than wall damp-proof cores, or where there is a basement, lack of continuity of wall damp-proof cores is there. So, in these situations this may happen. In case of decay of sandstone plinths, the attributed factor has been washing from limestone wall above. Means if the washings are coming from the limestone wall which is above, then certainly there will be a decay of the sandstone plinth. Blistering of surface is attributed to atmospheric pollution, wherein sulfur dioxide is absorbed into rainwater to form a weak acid solution which attacks the binding medium of the stone. Means the binding material in the stone that will be attacked by this acidic solution. The masonry walls and floors in factory buildings are affected by the vapors, gases and effluents from the chemicals. To avoid this, what we can do? Gases should be taken away by chimneys and stacks. The effluents should be drained off from the building without affecting the building components. Now we move to strengthening and repairing techniques. Many defects are encountered in the masonry and it is necessary to strengthen for proper use of the building. However, the problems in different buildings are not the same. They have multiple combinations and many a times have different concepts of their structural framework. Hence, to arrive at the most appropriate strengthening technique, it needs a good understanding, special attention, experience and care. Visible repairs would lead to the indication of quantum of invisible repairs and extent of repair activity and expenditure required in the building. This gas work requires lot of experience and it is an individual expertise. Cracks in the partition walls would also indicate direction and location of the problem. Cracks over the openings would indicate behavior of the external walls. Separation cracks along columns, junctions with walls, local crushing of walls, spalling portions, sagging and hogging of flooring systems would indicate the nature of damage and repairs required there. The masonry can be attacked from leaching and acid attack. Although a building may be perfectly dry when constructed, limestone or carbonaceous sandstones may become progressively more porous as the carbonate content is leached away by the rainfall. In polluted urban and industrial areas, the much stronger sulfur and nitrogen acids may be formed in rainfall, greatly increasing the rate of carbonate erosion and even causing slow deterioration of silica. The impervious carbonate such as marble will be subjected to surface etching, whereas a stone with high total porosity will tend to retain moisture due to limited ventilation of the pores and powerful capillarity. When water retention occurs in this way, it permits protracted absorption of atmospheric pollutants and thus prolonged acid attack on the stone components, and hence deterioration tends to be more severe. Before discussing the strengthening techniques, it is better to understand the properties of stone and brick masonry. As you know, stone masonry is stronger and more durable than brick masonry. While stone is a natural material, brick is artificial material. Brick absorbs moisture and is liable to make the building damp. With dampness, certain salts also rise in the walls from the ground, which may weaken the structure. Although stone is stronger than brick, the brick, if of good quality, is sufficiently strong for ordinary purposes and more convenient when protected by cement plaster on exposed surfaces, because working is easy with a brick in comparison to stone. Strengthening of masonry may be necessary not only due to deterioration of masonry but due to other reasons also, like increased load capacity, then change of use, then poor construction, then poor design. If these factors are there, then strengthening of masonry is required. In order to take appropriate action, we need to examine each case in turn, as the deficiency is usually the result of one or more factors in case of stone and the brick masonry. What are the different factors that may cause the deficiency in the building? First is plaster cracks. You might have seen in the first is plaster cracks. Generally, the brick wall has much lower thermal expansion compared to cement plaster, and thus it causes differential movement at the interface during expansion and contraction, leading to the cracks in the plaster. This is the main reason of the cracks in the plaster. If the cracks are not severe and profuse, periodical painting with cement based paint may offer some solution. However, removing the old plaster and doing it with the plaster of compatible characteristics with that of the base material can only offer a permanent solution for this, because the problem was because of different expansion and contraction properties. So if we are having, or if we can choose some material which is having the expansion and contraction properties close to that base material, means the bricks, then certainly this solution will be more permanent. When sand used for plastering is very fine, or it contains more silt or decayed vegetation beyond tolerance limit or the tolerance level, then closely spread random cracks may occur. Lack of adequate cement content or use of adulterated cement can also contribute to this problem. If the problem is not very severe, painting periodically with cement based paint should be enough. Where plaster has started disintegrating and debonding from the base, how you can identify it? Just knock it, you will get a hollow sound. So it is indicated by hollow sound produced on tapping the surface, and redo the plastering using proper material and with adequate supervision. Quite often there is a tendency to give a very smooth finish to the cement plaster after the floating course, often using fine sand or extra cement. If this practice is resorted to during very warm climatic condition, then what will happen? Discontinuous starry surface cracks may occur, particularly during drying process under windy conditions. Therefore, it is advisable not to give extra smooth finish to cement plaster. What we can do alternatively? A reasonable smooth surface can be obtained by applying putty to the wall surface while doing painting. Wherever extra smooth surface is needed, lime water can be used. Efflorescence in the walls. Where soluble salts are present in excessive quantities in the bricks or the mortar, they absorb moisture either from the air or during construction, and are brought to the surface in solution and deposited in concentrated patches, either as a white powder or as translucent crystals as the moisture dries out. After drying of the moisture, you will see either the white powder or the translucent crystals. So, this crystalline growth either flakes off or is reduced to a powder which can be brushed off. Attempts to seal back the efflorescence are not usually successful, and it is advisable to allow the efflorescence to expand itself as the wall dries before attempting any treatment at rendering or whitewashing the walls. Soluble salts can be removed by repeated washings with water and brushing the face of the masonry. Salts from small patches can be extracted by troweling on the surface a layer of slacked lime about 6 mm thick made up of a stiff paste. This is left in place until dry and then removed, and wall is brushed down. Salts from brickwork can be removed with a solution of zinc sulfate and water. How? The surface is brushed off when dry. A solution of 1 part hydrochloric or sulfuric acid and 5 parts water is applied vigorously with scrubbing brushes. Water being constantly sprayed on the work with a hose to prevent the penetration of the acid. Means one has to be careful that acid should not penetrate into the wall, otherwise it will further deteriorate. This will remove white or yellow blotches, means the patches or the spots from floors or walls due to efflorescence. Cleaning of external brick walls after completion of the building can be done with a 5% solution of muriatic acid. Muriatic acid is another name for hydrochloric acid. The walls must be thoroughly washed with copious flow, means large quantity of clean water both before and after the application of the solution. A mortar can be made as follows, which is waterproof and will also be useful in preventing efflorescence. How we will make this waterproof mortar? Take 1 part of cement, 2 parts of sand and add 12 kg of pulverized alum to this for each cubic meter of the sand. This is the constitution of this. Mix all the 3 dry and then add the proper quantity of water, and in this water what we have added, add 75 grams of soft soap per liter of water and then mix it thoroughly. So, you will get a waterproof mortar. It will also prevent the efflorescence. Now, we move to treatment of masonry walls. Water ingress through solid walls in the form of moisture from the exterior to interior due to porosity of masonry. More rapid penetration is through the mortar joints, and an efficient pointing on the exterior will greatly resist the passage of water. The simple flush pointing will offer good protection. If any waterproofing compound can be added to the mortar in pointing, cavity walls afford sound protection and ensure a dry interior even if porous material is used for outside. The application of a non-porous rendering on the external surface will do much to prevent direct penetration of moisture. In case of aggressive chemical environments, the solution would be to provide an epoxy coating after the brick wall is plastered with cement mortar. Epoxy coating can be done in the following sequence. Allow the plastered surface to dry fully, then clean the surface thoroughly, apply epoxy formulation using araldite binder, that is GY257, and hardener HY840 with quartz sand as the filler. Being a quick setting mix, the epoxy coating should be applied and finished within 30 to 60 minutes depending upon the pot life specified for the product used. Now let's move to a case study of arresting cracks in masonry walls. When load bearing walls show cracks localized in patches, lintels can be introduced to overcome the uneven distribution of load. This method is most suitable in cases where the cracks are due to uneven distribution of loads in bearing walls. Quite often, this technique is employed in cases where progressive deterioration may lead to irreparable losses. Introducing a lintel in the load bearing wall should be carried out with caution and care. Opening in the walls must be made after providing sufficient support to the load bearing wall. Here in the figure, you see the nature of the problem, means the crack pattern is shown here. What is the nature of the cracks? You see mostly the diagonal cracks here. So introduction of the lintel is done to arrest the cracks to extend beyond the lintel. So as you see here, that lintel can be provided in the wall to arrest these cracks. Let us see the step by step procedure to repair a cracked wall. Here you see in the figure the details of a cracked wall. A crack you see on the left figure. This type of cracks are very common in load bearing walls. The cracks are primarily due to differential settlement. So what we can do? First step, the crack is identified on either side of the load bearing wall. Causes of the cracks are analyzed. The next, approximately at 1.5 meter to 2 meter vertical spacing, precast RCC slab with normal reinforcement, and the size of this slab 400 by 230 by 100 mm are introduced across the crack line. So if crack is like that, so across it you provide it. The repair work is finished with commercially viable filler material in between the precast member and the wall. The crack line is widened and filled with the filler material. 2 courses of cement based paint is given later for restoring the appearance, because appearance is also important. Along with that, structural behavior or structural strengthening. So this is the way how we can do this. So this way you saw that in this lecture we discussed about the classification of defects, in which there were 2 types of defects, structural or physical defects, and the defects due to chemical action were there. Then we discussed about the strengthening and repair techniques, and finally we discussed about a case study which was regarding the arresting cracks in the masonry walls. I hope you must have enjoyed this discussion. Go through the text and enrich your knowledge. Thank you.